How's everyone doing? Sleepy? So last time we talked about more graphs, that good stuff. And guess what we're going to talk about today? More freaking graphs. I can't remember which one we left off, so let me check. Okay. So it looks like we left on, I think this is called ogive or ogive. I don't know how to say it properly. So can everyone hear me online okay? Cool. All right, so before we get started, does anyone have any questions? Cool. Just a reminder, your first homework for chapter 1 is due today at 11:59, I believe. Your chapter 2 homework is open, so if you want to get started on that, you can. Okay, so let's get rolling. So remember how we calculated cumulative frequencies in those little tables? This is where we're going to use it. So the ogive is a graph that represents the cumulative frequency for the classes in a frequency distribution. So what goes on the x-axis? So what do you think? What went on the x-axis when we plotted histograms? Class boundaries, so that's what we're going to use. So on the x-axis, we're going to have the class boundaries. And what are we going to plot on the y-axis? It tells us right here the cumulative frequencies. So cumulative frequency. So again, you could also do a cumulative relative frequency on the y-axis, but we're not going to do that. Another example is in your book, just like all the other relative frequency ones. Okay, so when plotting an ogive, you must plot the cumulative frequency at each upper class boundary. So remember how we had all these class boundaries right here? So we're going to plot the cumulative frequency up to this class at the upper boundary. Does that make sense? Did I just confuse you all? Okay, I'll show you in a second. So to illustrate this, you have to try an example. That way you kind of get the feel for it. So on the x-axis, again, we're going to have the class boundaries. On the y-axis, we're going to have the cumulative frequency. And what's the largest number that the cumulative frequency can take on? How many numbers are there in the data set that we're using? 20. So the highest it can go is 20. So how I scaled it was by 4. So we had 4, 8, 12, 16, and 20. Okay, so now we want to do our class boundaries. So since we want to plot them at the upper boundary, we're going to plot the upper and lower boundary actually for the first class, and then it's just going to keep going on from there. So for instance, the first point is going to be 100.5. The second will be the upper boundary of that, 104.5. And from there, we have 108.5, 112.5, 116.5, 120.5, 124.5, golly, there's too many, 128.5, and 132.5. Okay, so since it said we're going to plot the cumulative frequency, where'd it go? At the upper class boundary, what will be the cumulative frequency at 100.5? That's going to be our starting position because there is no cumulative frequency at the lower boundary. Does that make sense? We're plotting it at the upper boundary. So at the lower boundary, we're going to have 0 as its cumulative frequency. So this will be our 0 point. So, and then at 104.5, that's going to be the cumulative frequency of the class 101 to 104. But that's our first class, so the cumulative frequency is just going to be its frequency of 2. Is everyone okay with that? So here we're going to have 2. Then you just draw a line to connect them. So there's that. Okay. Now we want to look at the next upper class boundary, 108.5. So that's for the class limits of 105 to 108. And the frequency in that class was 6. So the cumulative frequency will be 6 plus the frequency of this class, 2. So that's 8. So that's right here. Does that make sense to everyone? How I got that? It's also on page, where is it? Page 5, the cumulative frequencies, we already had them there as well. So then this next upper class boundary of 112.5 is going to correspond to the class of 109 to 112, and the frequency of that class was 2. So if we add 2 to the cumulative frequency up to 108, we get 10. Does that make sense? Because 2 plus 8 is 10. So here we're going to have 10. Okay. So now for the next one, we're going to plot it at 116. So that corresponds to the class limits of 113 to 116. And there is 4 points in that class. So 4 plus 10 will give us a cumulative frequency of 14. I honestly don't know how close I am getting to these marks, so sorry if it's a little off. So the next one we have is 120.5. So that corresponds to the class limits of 117 to 120. And the frequency on that within that class is 4. And we had the cumulative frequency up to the previous class was 14. So what is going to be the cumulative frequency up to 120.5? Yep, 18, correct. So next we have 124.5. So that is the class limits of 121 to 124, but there was no data points that fell within that class limit. So what's the cumulative frequency up to 124.5? 18 again, yes. Just stays constant. Okay, so now we're on the upper limit of 128.5. So that corresponds to the class limits of 125 to 128. And within that class, we had 2 data points. So our cumulative frequency will be that 2 plus our already 18. So that gives us 20. And the last upper class boundary of 132 there are no data points within the class limits of 129 to 132. So the cumulative frequency is what? 20. Stays the same, yeah. So that's what it looks like. The one you will see on the notes on Canvas is a little better. It's that. Not really much better, but a little bit. So, did that make sense to everyone? Okay, cool. Now we're going to talk about bar charts. Woo. Y'all probably heard of bar charts from high school, right? I would assume so. So, there are two types of bar charts we're going to talk about, and you call them bar charts or bar graphs, doesn't matter which one. We're going to talk about compound bar graphs and just regular bar graphs. So, the first one we'll talk about is just a regular bar graph. So, a bar graph, I hate how they have this thing set up. I can't keep it straight. A bar graph represents the data by using vertical or horizontal bars whose height or length represents the frequency of the data. So let's look at an example. So here we have different classifications. So whatever class you're in, freshman, sophomore, junior, senior, and we have a count, so a frequency. So frequency is going to go on the y-axis, and the classification is going to go on the x-axis. So down here we're going to have freshman, sophomore, junior, and senior. So I would assume most of you in here are freshmen. I don't know though. Nope. I know there's some seniors in here, and I was like, a senior is taking this class? I mean, you do you. So now we want to look at what's the highest count or our highest frequency, and it's 12. So to make it easy, I'm going to go by threes. So we have 3, 6, 9, and 12. Okay, so now we want to make the height of these bars the frequency of that classification. So for freshmen, we have 9. So, and it's going to look like this. So freshmen have a bar of height 8. You can't really tell where it's at because it's in between 6 and 9, but you can put an A on the top to represent the 8. So then we're going to do the same for sophomores. So sophomores, there are 12 of them. I'm technically a sophomore in grad school. So make it all the way up 12. Pop it off, and then write the frequency on the top. You don't have to write the frequency on the top. It just makes it easier to know what the frequency of that class is. So, oops, wrong pen. For juniors, we have 9. So it's going to look like that. Go across. Doop. Okay. And then, so that will be 9. And then for seniors, we had 11. Okay, so that'll be around here. So, does everyone think they can make a simple bar graph? Golly, I hate when this light turns off. Okay, so the next one we're going to talk about is a compound bar graph. So we can use this to compare like two different things. So the way I have it is, where's it at? We'll just do this. So again, we have classification, and we're going to have frequency on the y-axis again, But we're going to break up each of these bars into whether they are male or female. So we have frequency over here and classification over here. So again, we're going to have freshman, sophomore, junior, senior. And I kept the same scale, 3, 6, 9. 12. Okay, so now what we want to do is use different colors. So I have blue and red for the different bars. So for males, let's use blue. Who in the world left me a voicemail? So for freshmen that are male, we have 3. So draw a bar up to 3. And then for freshman females, we have 5. So draw a bar to 5. And usually how I do it is I will make a legend, that way you know which one is which. So female is red, male is blue. So next, for sophomores, we had 8 male sophomores. So the height of the male bar will be 8. So that's close enough. Okay. And then for the females, we had 4. So it's going to be a little higher than this 3. It'll be right around here. Okay. Then we're going to do the same thing for juniors and seniors. So there's 6 male juniors. So we have a height 6 bar. So about right there. Then we have a height 3 bar for the females. So right here. Then for the juniors, we have 2 males and 9 females. So 2 males is like that. And 9 females is up here. Ta-da! That's how you do it. Does that make any sense? So basically, you're just splitting this bar into 2 different bars, 1 female and 1 male. And that's what you call a compound bar graph, and we use it to compare data for 2 or more groups. So they kind of look like a histogram, but there is a couple differences between bar charts and histograms. So the first one, a bar graph is used when the data is qualitative or categorical. So does everyone know why we used a bar chart here? Because what is classification? Categorical. So the other one, so we use histograms to show the distribution of variables. So whenever we have histograms, we can talk about these different shapes and distributions. So a histogram is used to show the distribution of variables while bar charts are used to compare variables. So here we had male and female. We want to compare the 2 and see which one has more frequency in a certain class. So bar charts are used to compare variables. So, does that make sense to everyone? Holy cow, how many more do we have? 3? 4? How many do they test you over in the homework? Holy cow, they literally do every single one on the homework. Why are they so mean? So, the next one we're going to talk about is called a Pareto chart. You probably never heard of that. I had never heard of it until 2 years ago. So, a Pareto chart is used to represent a frequency distribution for a categorical variable where the frequencies are displayed from highest to lowest. So, a Pareto chart, that's the first one. And highest to lowest. So that means we're going to order the height of these bars from the tallest to the shortest. Does that make sense? And it doesn't matter about the classification. So, again, we're going to have classification on the x-axis and frequency on the y-axis. We have classification. And frequency. Is everyone online following along with all of these graphs? Cool. Sorry, there are way too many. So, what we want to do is look at the class that has the highest frequency and then go down from there. So, again, I made the x or the y-axis scales of 3. So, what we want to do is the first classification we're going to have is sophomores, because sophomore has the highest frequency. Does that make sense? And the height of that bar will be 12. Then next, we're going to have seniors, because they have 11. So we have seniors, and their bar is going to have height 11, so just below that. Then, who will be next? Yup, juniors of 9. So we go here, over, down, and we label it as juniors. And then what's the remaining one? Freshmen, fresh meat. So over and down. That'll be freshmen. So that's how you make a Pareto chart. Just do the highest frequency to the lowest frequency and make sure you label the classification on the x-axis or whatever the categorical variable is, and then that way it makes sense. Do they need to touch? I make them touch. It's just easier. That's how all publications do it, so yes, I would have them touch it. Okay, so that one was easy peasy. So now we're going to compare frequencies or percentages over a time frame. So what do you think this would be called? A time series graph. So a time series graph represents data that occurs over a specific time period. Sorry, someone's typing in the chat, so I'm waiting to see what they say. Only Pareto charts are graphed from highest. Yes, that's correct, Lexi. So the Pareto graph is the only one where we're going to order the frequencies from highest to lowest. Every other one, we're just going to order in terms of the classification or order of the rank of a person. Does that make sense? You're welcome. So, golly, all the stat students munching off me for some homework answers. They ain't getting them. So, let's go over an example, and it kind of illustrates this. So, the data show the percentage of U.S. adults who smoke. So, on the x-axis, we're going to have the year. So, this will be year. And this will be percent. So, we want to see how the percentage of U.S. adult smokers changes over this time frame. Does that make sense? Oops, I need to scoot that up. So, we're going to go from 1970 to 2010. So, let's say right here we have 1970. Here we have 1980, 1990, 2000, and 2010. So, on this one, I started at something other than 0. So here, I made my starting point 19, so 19%, and then I went up by 3s. So I had 22, 25, 28, 31, 34, and 37. So now what I want to do is graph the percent of smokers in 1970 with just a dot. So in 1970, we had a percentage of 37, so that's the highest one, so that'll be up here at 37. So what do you think we want to do next? Do the one for 1980. So for 1980, we had a percentage of 33. So 1980, 33, be around here somewhere. So then we're going to do the same thing for 1990. So 1990, there were 25%. So that will be right here. So there was a little drop off. And then in 2000, not 200, 2000, we had 23%. So that's about right here, I guess. And then in 2010, we had 19%. That's the lowest one right there. So you can connect all the dots, and you can see how the percentage of people who smoke in the United States has gone down since 1970. And how much has it gone down by? So it's 37 minus 19. So it's gone down by 18% in the last 40 years. So, know how to read that. I could put that on an exam. So does that make sense? I'll leave that light. It just makes it moody in here. Okay, so is everyone okay with time series? It's pretty easy. So next is the dot plot. So I think we know what a dot plot is. So a dot plot is a statistical graph to which each data value is plotted as a dot on the horizontal axis. So we have dot plot here. So, and we want to try an example to illustrate how to draw a dot plot. So, it says draw the dot plot for the data above. So, we have numbers ranging from 0 to 4. So, I'm going to do 0, 1, 2, 3. That is an ugly 3, 3, and 4. Make sense? Okay, so now let's go down the data points and each plot them with a dot. So first we have 1, so a dot for 1 and mark it out. Next is a dot for 0, mark it out. A dot for 2. So I already have a dot for 1, so where does the dot for this next one go? Right above the first one, so put it right here. And then again, same thing for 2. For another one. And now we have 4. That family had some fun. 5 kids. Next is 0, like the number of girls that like me. Self-roast. Number 2. And then again, a number 1. So, can anyone comment on the distribution of that? Ba-dum TS. What does that mean? Ba-dum. Oh, okay, I see. So, can anyone comment on that distribution? What type is it? If I draw a curve over this, what does it look like? Is it skewed to the left? Close. It's skewed, but not to the left. Yeah, skewed to the right. So, notice how it tails off right here. So, skewed right. So, on the exam last semester, I think I put a histogram one, and you had to draw the histogram and comment on the distribution. So, is that easy enough? Literally putting dots on numbers. So, what's up? Someone's asking something. Okay, they're still typing. We'll go to the next one. So asking to describe the distribution is just saying if it's skewed or something, yes. So it's asking if it's skewed, uniform, symmetric, bell-shaped, J-shaped, U-shaped, whatever. So that would be, so we could talk about all the distribution shapes we had on page 8. The most common ones we talk about are bell-shaped, uniform, and left skewed and right skewed. Does that answer your question, Abby? Cool. So, now that we did a dot plot, the next one is a stem and leaf plot. Golly. Who dat? Oh, it's my mom. Jesus. What? I'm looking at the next chapter's notes to see what we're going to go over. Ooh, so much fun. Golly. Okay, so this next one is, as I said, a stem and leaf plot. So a stem and leaf plot is a data plot that uses part of the data value as the stem and the other part as the leaf. So in this case, we just have numbers. So first, I'm going to try an example. So our stem is going to be the tens place, and the leaf is going to be the ones place. So we're going to go from, let's see, the lowest number we have is 63, and the highest is 100. So we're going to go 6, 7, 8, 9, and 10. So now let's go down and do this. So the first one we have is 91. So there's a 1 in the leaf spot. There's a 1 in the ones place. So 91 will be that one. Okay. So 92 will be the next one. So right next to this, we're going to have a 2. So the next one will be 86. So here we'll have a 6. Next we have 71. So a 1 goes by the 7. We have an 82. So that goes right there. Then a 63. Then a 100. Then a 98. A 75. 86 again. So even though 86 occurs twice, you still have to write each 6. That way we know how many numbers in the data set. So if we did just put just 1 6 down, that means there's only 186 up here, and that's wrong. So then we have 88 and 67. So the way we usually do it is we want to put these leaves in order. So this one's already in order, so 3 and 7. This one's already in order, 1 and 5. This one will go 2, 6, 6, 8. Does that make sense? So just putting these leaves in order. And then this one right here is already good, and that one's already good. Where did I put my phone? There it is. So, is everyone okay with the stem and leaf plot? That was loud. Okay, you could also do this to look at the shape of the distribution. So you turn it sideways, and you can draw a curve over it. So what would you say about that one? You could say it's mostly symmetric, or you could say slightly right skewed. Either one. Okay, so is everyone okay with the stem and leaf plot? The next one is this the last one? Please tell me it is. The pie graph. So you could also call it a pie chart. So, a pie graph is a circle that is divided into sections or wedges according to the percentage of frequencies in each category of the distribution. That may help if I flip the page over. Oops, I just unhooked that. My bad, peeps online. There. Now please work again. Dang it, I gotta connect it again. Okay, there. Sorry about that. Could not start video source. Shut up. Come on. I may have to turn it off and turn it back on. Come on, turn off. Sorry, this thing is being a pain. And I don't know why. There, now let's see if it works. The HDMI cable is almost out. Come on. Okay, until that decides to work, I'm gonna have to do this. Modules. Stupid thing. Okay. So, I'm just gonna have to go through this. Since that thing is not working for some reason. Why the heck is it making that noise? Today is just sucking. Okay, so we were on pie graph. Way down here. So, a pie graph is a circle that is divided into sections or wedges according to the percentage of frequencies in each category or of the distribution. So how do we create a pie chart? So I put a few steps there. So number one, we want to calculate the degrees for each category. So that's how many degrees of the pie chart that certain category will take up. So the way we're going to do that is, so the degrees is equal to the frequency of that certain class or category, whatever it is, over the total frequency. So that'll give us a percentage right here. So the relative frequency of that category or whatever it is times 360 degrees. And that'll give us the degrees of that certain category. So does that make sense to everyone? Okay. And then the next thing we're going to do is calculate the percentage of frequencies in each category. So the percentage is equal to the frequency over the total times 100%. So y'all should know how to do that. It's basically just taking the ratio and then moving the decimal over 2 places to the right. Does that make sense to everyone? So, the third step, use the appropriate degrees calculated in step 1 to draw the graph. And then we want to label each section with the corresponding percentage we found in step 2. Okay, so does that make sense? So to illustrate that, we want to look at an example. So the frequency distribution shows the number of pounds of each snack food eaten during the Super Bowl. So construct a pie graph for this. So what we first want to do is find how many degrees each category is going to take up. So the first thing we need to do is find the total of pounds. So that's what our frequency is, I guess, in this case. So what we want to do is take $11.2, add 8.2, 4.3, 3.8, and 2.5 together, and you'll get 30. So the total pounds in millions is 30 million. So now that we know the total, we can find the degrees for each category by taking the frequency over that of that category divided by the total frequency. So for this potato chip one, what I want to do is take 11.2, divide it by the total, which was 30. And that'll give me 0.373333 repeating. And I want to multiply that by 360. And that'll give me 134.4. So I rounded that down to 134 degrees. So does that make sense for everyone, how I did that? So then to find the percentage of that, I literally had, so I already took the frequency over the total frequency, so that was 11.2 over 30, and that gave me 0.37333 repeating. So what I want to do is multiply that by 100%, so just multiply it by 100, and that'll give me 37.333, so I just put 37.3%. So that makes sense to everyone? Okay. So for the next one, we want to do the same thing. So to find the degrees that it tortilla chips are going to take up in the pie graph, we're going to take the frequency of that class, so 8.2, divided by the total, 30. Then we want to multiply that by 100 to get the percent. Multiply it by 360 to get the degrees. And that'll give you 98.4 degrees. So I rounded that down to 98. Okay. So, and then to find the percentage, so I already took the ratio of the frequency over the total. So that was 8.2 over 30. And then I want to multiply that by 100. And that gives me 27.3%. So that's where I have the 27.3 from. Then we want to go to pretzels. So we take the 4.3 over the total, 30, then multiply that by 360, and that'll give us 51.6 degrees. So I rounded that up to 52. Make sense? Cool beans. So, and then we found the ratio of 4.3 over 30, which is equal to 0.14333. Then to find the percentage, I just multiply that by 100, and I get 14.3%. Have I lost anyone yet? Have I bored you all? Probably. So, next one will be for popcorn. So you have 3.8 divided by 30. That's 0.126666666 times 360, and that'll give you 45.6. So I rounded that up to 46 degrees. And to find the percentage of that, we had 3.8 over 30 was equal to 0.1266666. So just multiply that by 100, and you get 12.666666. So I just rounded it to 12.7%. So, and then for snack nuts, 2.5 divided by 30 again, that'll give us 0.08333. So times that by 360, and we get 30 degrees. Exactly. So, and then to find the percentage, I just take that 0.0833333 and multiply by 100, and that'll give me 8.33333. That's how I got that. So, you want to check that these total degrees add up to 360, which they do. And the percentages are roughly adding up to 100%. That's just because rounding error. Because whenever we have those like 0.33333, I just rounded. So it's going to be close to 100%. It may not be exact. So, and then to do the pie chart, I want to start with potato chips. So I have potato chips, took up 134 degrees. So I want to do a little bit less than 180 degrees. So it looks somewhat like that. And then I put the percentage inside of the wedge, and then I label the wedge. So then I want to do the same for tortilla chips. So tortilla chips take up 98 degrees, so just a little bit more than a right angle. So, and then put the percentage inside and label it. You want me to go over the other three or not? Is that easy enough? Cool. Okay, so now is the review part of chapter 2. Oopsies. Let's see if I can get the document camera to work yet. Nope, will not. So next is the review part of chapter 2. And y'all can work on that here together or whatever, and then I'll walk around, and then we will finish it up. Hey, Abby, sorry, I just saw your question. If you're generally close, I'll give it to you. Can you all hear me now? Okay. So let's look at this little review thing first, and then we can get out of here. So, the age of 20 dogs and a pet shelter are shown below. We want to construct a frequency distribution using only 5 classes. So, the first thing we want to do is determine the class width. So, we take the range. We want to find that first. The range is equal to the highest number minus the lowest number. And here the highest number is 9 and the lowest number is 1. So our range will be 8. So then our class width is equal to the range over the number of classes. So that's 8 over 5, which is equal to 1.6. And remember that if class width is a decimal, we always round up to the next whole number. So the class width would be 2. So then we want to create a frequency distribution. So the lowest number we had was 1, so that's going to be our starting point. So to find the class limits, to find the lower limit of this class, we take 1 and add the class width, so that's going to be 1 plus 2 is 3. And to find the upper limit of this one, we take 3 minus 1, and it equals 2. And we keep doing that all the way to 10. So we have 3 plus 2 is 5, minus 1 is 4. 5 plus 2 is 7, minus 1 is 6, and 7 plus 2 is 9, minus 1 is 8. 9 plus 2 is 11 minus 1 will give you the upper boundary of 10. So then to find the class boundaries for each of these, I take 0.5 off of the lower one and add 0.5 to the upper. So here I have 1 minus 0.5 is 0.5. 2.2 plus 0.5 is 2.5. All the way down to 9 minus 0.5 is 8.5. 10 plus 0.5 is 10.5. So then to find the class midpoint, I just take the lower and upper class limits, add the 2, and then divide by 2. So if I do that, that is 1 plus 2, which is 3. Divided by 2 is 1.5. And then as we noticed earlier, you can just add the class width to each one, and you'll get the next one. So 1.5 plus 2 is 3.5. 3.5 plus 2 is 5.5. All the way down to 7.5 plus 2 is 9.5. So is everyone okay with that so far? So the next one we want to do is the frequency. So we need to see how many numbers in between 1 and 2 lie in this data set. So we have 1, 2, 3, 4. So the frequency of that one is 4. So then the relative frequency is equal to the frequency of this class divided by the total frequency, which is 20. So it'd be 4 over 20, which is equal to 0.2. And then the cumulative frequency would be 4 because this is the first class. So the cumulative frequency of the first class is just the frequency. So next we want to find the frequency between 3 and 4. So we have 1, 2, 3, 4, 5. So the frequency of that one is 5. So then the relative frequency would be 5 over 20, which is equal to 0.25. So, and then to find the cumulative frequency of that, I take the frequency of this class and add it to the frequency of the one before. So that's 5 plus 4, which equals 9. So then the next one, 5 to 6. So we have 1, 2, 3, 4. So the frequency of that is 4. So then the relative frequency will be 4 over 20, which is equal to 0.2 again. So, and then the cumulative frequency would be this cumulative frequency, 9 plus the frequency of this class, 4, to give you 13. Okay. Then we go on to 7 and 8. So we have 1, 2, 3, 4, 5 again. So the frequency is 5. The relative frequency is again 5 over 20, which is 0.25. And the cumulative frequency up to there is equal to 13 plus 5, which is 18. And then for the next one, we have 9 to 10. So we have 9 and 9 here. So that's a frequency of 2. With a relative frequency of 2 over 20, which is equal to 0.1. And then the cumulative frequency is 18 plus 2, which is 20. So the next thing we want to do is draw the histogram, the frequency polygon, and the dot plot for the data above. So on the x-axis goes our class boundary. So what I did was just label the x-axis as the age, because that's what is changing. So age in years, you could also put class boundaries, and you just do the class boundaries. So we have from 0.5 up to 10.5 in increments of 2. So here I have 0.5 to 2.5 is the class limits of 1 to 2, and the frequency there is 4, so there's a bar of height 4. And the next one, 2.5 to 4.5, is the class limits of 3 to 4, so the frequency is 5, so I have a bar of height 5. Next one, I have another bar of height 4 for the class boundaries of 4.5 to 6.5, which is the class limits of 5 to 6. Then the next one is 6.5 to 8.5, which is corresponding to the class limits of 7 to 8. and the frequency of that is again 5, so we have a bar of height 5. And the last one is 8.5 to 10.5, which corresponds to the class limits of 9 to 10. And the frequency there is 2, so the height of that bar is 2. So here for the frequency polygon, so what I've been doing, I think it's correct. So we have this class midpoint here, the first class midpoint, and then my starting point is what would be the class midpoint before this one. So I take 1.5 minus the class width, and it would give me the class midpoint of that preceding class. So, and that's what I call my 0 point. So negative 0.5 has 0 frequency. The class midpoint of 1.5 corresponds to the class of 1 to 2 with a frequency of 4. So I have a dot at 4. Then the next one goes to 5, then to 4, then to 5, and then to 2. Then the class midpoint of 11.5 is my ending point. So that's what would be the class midpoint if there were another class after 9 to 10. So does that frequency polygon make sense to everyone? So the next thing we want to do is draw a dot plot. So I did that here. So we have 2 1s, 2 2s, 2 3s, 3 4s, 3 5s, 1 6, 3 7s, 2 8s, and 2 9s. So, and then I ask you to comment on the distribution, comment on the shape of the distribution. So if you draw something over it, it ends up looking like a hump here, down, then a hump here of the same height, and then back down again. So the distribution will be bimodal. So does that make sense to everyone how I did all that? All right, cool. So I will post the completed notes now. Let me go in here and do it. And then if you didn't get some of it, you should be able to get it now. And then, so your homework 1 is due today. Your homework 2, I don't know when it's due yet. I'll have to change the date. I'll probably make it due a week from today, so whatever day that is. And that's it. Y'all enjoy your weekend and see y'all next Tuesday.